According to the National Electrical Code, Section 210.11 Cone, a bathroom light fixture is required to be on its own circuit. This ensures that a fault in a lighting circuit won't affect other critical circuits in the bathroom, like those serving outlets near water sources. Now, let's address kitchen appliances. Not every appliance in the kitchen needs its own dedicated circuit. However, the National Electrical Code, Section 210.52, mandates dedicated circuits for certain appliances like refrigerators, dishwashers, and garbage disposals. This is because these appliances typically draw a significant amount of power and require a reliable power supply. Moving on to bedrooms, the National Electrical Code, Section 250.138a, specifies that bedroom outlets need to be arc fault circuit interrupter protected. Arc fault circuit interrupters are designed to detect dangerous electrical arcs that can cause fires. While it's not mandatory for each bedroom to have its light on its own circuit, it is generally recommended to have each bedroom light on a separate switch. This allows for individual control of lighting in each room. Let's consider replacing two prom outlets with ground fault circuit interrupter outlets in older homes with two-wire systems. The National Electrical Code, Section 406.4 done allows this, even in 1950s era wiring. As long as the ground fault circuit interrupter outlets are properly installed, this provides a level of safety comparable to grounded outlets. Ground fault circuit interrupters detect ground faults and quickly cut off power, preventing electrical shocks. You can replace the wiring running from your electrical panel to lights and outlets while leaving the wiring from switches in place. The National Electrical Code, Section 300.11, requires that the new wiring is properly sized and installed. This means using the correct gauge of wire for the intended load and ensuring all connections are secure and insulated. Finally, it's permissible to replace some of the existing wiring while leaving other portions in place, provided the new wiring is properly sized and installed. Again, National Electrical Code, Section 300.11 is relevant. However, it's generally best practice to replace all of the old wiring if feasible. This ensures a consistent and reliable electrical system throughout your home. Here's a more detailed breakdown of the points we covered. Firstly, bathroom light circuits need to be separate, offering safety and preventing cascading failures. Secondly, kitchens have dedicated circuits for high-demand appliances, ensuring proper operation. Thirdly, bedrooms require arc fault circuit interrupter protection, preventing electrical fires. Fourthly, bedroom lights do not need dedicated circuits, however individual switches for each room are helpful. Fifthly, upgrading two prong outlets to ground fault circuit interrupter outlets is code compliant. Sixthly, partial wiring replacements are allowed if new wiring is up to code. Seventhly, complete rewiring is preferred for overall system reliability. To elaborate on the National Electrical Code references, let's delve deeper into what they entail. National Electrical Code Section 210.11 Cone concerning bathroom branch circuits specifically mandates that a 20-amp circuit must supply only bathroom receptacle outlets. This rule aims to prevent overloading of the circuit due to the concurrent use of multiple high-power appliances such as hairdryers and curling irons. Furthermore, it enhances safety by reducing the likelihood of nuisance tripping of the circuit breaker. National Electrical Code Section 210.52 addresses receptacle outlet placement in dwelling units, including kitchens. It details the requirements for spacing of receptacles along countertops and walls to ensure that appliances can be conveniently plugged in without the use of extension cords, which can pose safety hazards. Specific requirements are outlined for countertop spaces, peninsula countertops, and island countertops. National Electrical Code Section 250.138 relates to the permissibility of using ground fault circuit interrupter protection as a means of providing a grounding electrode for replacement of non-grounding type receptacles. This is permitted where a grounding means does not exist in the receptacle enclosure. The ground fault circuit interrupter protection offers a significant safety upgrade in such situations by quickly interrupting the circuit in the event of a ground fault. National Electrical Code Section 406.4 DUN provides additional guidance on replacing receptacles. It permits the replacement of two-wire, non-grounding type receptacles with ground fault circuit interrupter protected receptacles where no equipment grounding conductor exists. The ground fault circuit interrupter protection provides a level of safety equivalent to that of a grounded receptacle. National Electrical Code Section 300.11 covers securing and supporting wiring methods. It requires that wiring be securely fastened to the building structure and supported at appropriate intervals to prevent mechanical stress on the conductors and terminations. This helps to maintain the integrity of the wiring system and reduce the risk of damage or failure. When replacing wiring, it's crucial to adhere to proper wiring practices. This includes using appropriately sized conductors for the intended load, making secure and insulated connections, and protecting the wiring from physical damage. In addition, it's important to follow all applicable codes and regulations to ensure the safety and compliance of the electrical installation. When working with electricity, always take precautions to protect yourself from shock hazards. This includes turning off the power to the circuit before working on it, using insulated tools, and wearing appropriate personal protective equipment. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Consider the reasons for replacing wiring partially versus completely. Partial replacements can be suitable when specific sections of wiring are damaged or outdated, while the rest of the wiring is in good condition. However, complete rewiring is often recommended in older homes with outdated wiring systems. This ensures that the entire electrical system is up to current standards and provides a higher level of safety and reliability. Replacing all wiring eliminates potential issues with mixed wiring types or degradation of older insulation. Remember to properly size wiring according to ampacity requirements. The ampacity of a conductor is its current carrying capacity, which depends on the wire gauge insulation type and insulation conditions. The National Electrical Code provides tables and guidelines for determining the appropriate wire size for different applications. Using undersized wiring can lead to overheating and fire hazards. When making electrical connections, ensure they are secure and properly insulated. Loose connections can cause arcing and overheating, while inadequate insulation can expose energized conductors, creating shock hazards. Use appropriate connectors and splicing techniques to ensure reliable and safe connections. Remember to protect wiring from physical damage by using conduit, cable trays, or other protective measures. Wiring that is exposed to physical damage can become compromised, leading to electrical faults or failures. Conduit provides a robust layer of protection for wiring in exposed or harsh environments. Cable trays offer support and organization for multiple cables. If you encounter any unexpected issues or are unsure about any aspect of the electrical work, consult a qualified electrician. It's always better to err on the side of caution when dealing with electricity. An electrician can assess the situation, provide expert advice, and perform the necessary repairs or upgrades. The National Electrical Code serves as the cornerstone of electrical safety in the United States. Regularly updated, it provides comprehensive guidelines for electrical installations, ensuring the safety of people and property. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the National Electrical Code is essential for all electrical work. It is adopted by most states and municipalities, and adherence to its requirements is legally mandated. Understanding the National Electrical Code is crucial for electricians, contractors, and anyone involved in electrical work. It provides the knowledge and guidance necessary to perform electrical installations safely and effectively. It's important to stay up to date with the latest edition of the National Electrical Code, as changes and revisions are made periodically to reflect advancements in technology and address emerging safety concerns. Continuing education and training are essential for electrical professionals to remain competent and informed about code requirements. In addition to the National Electrical Code, many local jurisdictions have their own electrical codes and regulations. These local codes may be more stringent than the National Electrical Code and may address specific issues or concerns within the community. It's important to be familiar with both the National Electrical Code and any applicable local codes when performing electrical work. This ensures compliance with all relevant requirements and promotes the highest level of safety. Electrical inspections are an important part of the electrical safety process. The electrical inspectors review electrical installations to ensure they comply with applicable codes and regulations. Inspections help to identify potential hazards and ensure that electrical work is performed safely and correctly. It's important to schedule an electrical inspection after completing any electrical work, whether it's a new installation, a renovation, or a repair. This provides assurance that the work meets code requirements and is safe for use. The role of ground fault circuit interrupters and arc fault circuit interrupters in modern electrical safety cannot be overstated. Ground fault circuit interrupters are designed to protect against electrical shock by detecting ground faults and quickly cutting off power to the circuit. They are typically installed in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters are designed to protect against electrical fires by detecting dangerous electrical arcs that can occur in faulty wiring or appliances. They are typically installed in bedroom circuits and other areas where there is a higher risk of fire. Ground fault circuit interrupters and arc fault circuit interrupters have significantly reduced the number of electrical shocks and fires in homes and businesses. They are an essential part of modern electrical safety and are required by code in many locations. Consider the differences between aluminum and copper wiring. While copper is the more traditional and widely used wiring material, aluminum wiring was used in some homes built in the 1960s and 1970s due to rising copper prices. However, aluminum wiring has some drawbacks compared to copper, including a higher resistance to electrical flow and a tendency to corrode over time. Homes with aluminum wiring may require special precautions to prevent electrical hazards, such as using approved connectors and antioxidant compounds. It's important to have aluminum wiring inspected by a qualified electrician to ensure it is safe and properly maintained. Remember to label circuit breakers clearly and accurately. Proper labeling of circuit breakers is essential for troubleshooting electrical problems and ensuring safety. Each circuit breaker should be labeled with a clear description of the devices or areas it serves. This allows you to quickly identify and turn off the correct circuit when performing electrical work or responding to an emergency. In addition, it helps to prevent accidental overloading of circuits. Maintaining an up-to-date circuit directory is a good practice for any homeowner. When it comes to energy efficiency, consider using light-emitting diode lighting. Light-emitting diode lighting is a highly energy-efficient alternative to traditional incandescent and fluorescent lighting. Light-emitting diode bulbs use significantly less energy and last much longer, resulting in lower energy bills and reduced maintenance costs. Light-emitting diode lighting is also available in a wide range of colors and styles, making it a versatile choice for any application. Upgrading to light-emitting diode lighting is a simple and cost-effective way to improve energy efficiency in your home. If you're planning a home renovation, consider incorporating smart home technology into your electrical system. Smart home technology allows you to control various aspects of your home, such as lighting, temperature, and security, remotely using a smartphone or other device. Smart home systems can improve energy efficiency, enhance security, and provide added convenience. Integrating smart home technology into your electrical system requires careful planning and coordination with a qualified electrician. Finally, never attempt electrical work that you are not qualified to perform. Electrical work can be dangerous and should only be performed by trained and experienced professionals. If you are unsure about any aspect of electrical work, it's always best to hire a qualified electrician. This will ensure that the work is performed safely and correctly and that your electrical system is code compliant. Electrical safety should always be your top priority.